Hi everyone, we're going to find the partial fraction decomposition. This one involves repeated linear factors. So I'm going to take this and expand it with a over x plus b over x squared plus c divided by x minus 2 plus d over x minus 2 squared. Alright, so we'll get started and clear the fractions. And when you do that, you multiply everything by this term here, your least common denominator. So that crosses out and you get x plus 1. Here the x will cancel out and you're still left with x times x minus 2 squared. The x squared cancels out here, so you get b times x minus 2 squared. And then c, this cancels out, but we're left with x squared times x minus 2, just one of them. And then d, this whole thing cancels out, so you get dx squared. So I think the first thing I want to do is just let x be 0. Let's see what happens when we do that. If we let x be 0, then we're going to get 0 plus 1 equals a times 0 minus 2 squared plus b times 0 minus 2 squared plus c times 0 squared times 0 minus 2 plus d times 0 squared. The reason we chose that is because it zeroes out 3 of our terms. It zeroes out this one, and this one, and this one, so we can solve for b. Therefore, we have 1 equals negative 2 squared is 4, so 4b. Therefore, b equals 1/4. Now, the next one I'm going to use is let x be 2. Now, let's just look at this so I don't do too much writing. If I let x be 2, and I put a 2 in here, that's going to zero out. If I put a 2 in there, that's going to zero out. And I put a 2 in here. So the only thing we're really going to have is solve for d. So let's plug it in. If I do that, if I let x be 2, you get 2 plus 1. And what's going to happen is this, everything's going to zero out. I'll go ahead and write it out here, but you get 2 minus 2 squared. So that's a 0. So that zeroes that out. And it zeroes out the b, because you have 2 minus 2 squared. That's 0, so that zeroes that out. It's going to zero out the c, because you're going to have 2 squared and then 2 minus 2, so that's a 0. So the only thing we're left with is d times 2 squared, which is 4. So you have 3 equals 4d. Therefore, d equals 3 over 4. All right, so we have d equals 3 over 4, and b equals 1/4. And the rest of it, we're going to get a system of linear equations, like we did on the last video. So now we're going to go ahead and let x be 1. And when you do that, you get 1 plus 1. You always want to use small numbers. You could actually use any numbers, but you want to use the smallest numbers you can get. So we have 1 times 1 minus 2 squared plus b times 1 minus 2 squared plus c times 1 squared times 1 minus 2 plus d times 1 squared. So simplifying this, we get 2 equals negative 1 squared is 1, so 1 times a is just a. This is going to be 1 too, so plus b. Now this is going to be a 1, but this is negative 1, so that's minus c, then we have plus d. Now, I don't know what my a and c is, so I'm going to keep my a and c over here. Move everything else over, so you get 2 minus b minus d, and plug in that. So basically get a minus c equals 2 minus 1/4 minus 3/4, and all that equals is 1. So we're going to use this later for our system of linear equations. So remember that one. And now let's choose something. Let's choose 3. Let's just do something different. So let's let x equal 3. Alright, so when you let x be 3, we have 3 plus 1 equals a times 3 times 3 minus 2. The reason I did that is because I want to get a 1 here. It makes it a lot easier. When you get a lot of 1s, it makes it nice. 3 minus 2 squared plus c times 3 squared times 3 minus 2 plus d times 3 squared. Now that's going to yield 4, and that's a 1, that's a 1, that's a 1. So now you know I chose x equals 3. So we're going to get 3a plus b plus 9c plus 9d. Now I want a and c separate, so I'm going to keep my 3a plus 9d on this side and subtract the other two. So we get 4 minus b minus 9d equals that, 3a plus 9d. Now let's plug in our b and d. So that's going to be 4 minus 1/4 minus 9 times 3/4. And that all equals negative 3. So basically, we have 3a plus 9d equals negative 3. I'm going to go ahead and divide everything by 3. And then finally, we have a plus 3d. Let's see. 3c, sorry. Where am I getting the d? This was c. This should have been a c. Sorry about that. Y'all saw that, right? All right, so let's clean this up a little bit. So now we're going to get a plus 3c equals negative 1. All right, now write my system down from the other slide, and my system's going to be a minus c equals 1, and a plus 3c equals negative 1. And we're going to go ahead and subtract here. So if you subtract, you're going to get, or we can use substitution. Let's just use substitution. We'll have a equals c plus 1. And let's just use substitution. So when you have that, you have a plus 3c equals negative 1. And we'll substitute that in. So we get c plus 1 plus 3c equals negative 1. Therefore, we get 4c plus 1 equals negative 1. So 4c equals negative 2. Therefore, c equals negative 1/2. Now, plugging it back in here I have a equals negative 1/2 plus 1, and negative 1/2 plus 1 equals 1/2. So now we have everything. We have our a equals 1/2, our b equals 1/4, our c here equals negative 1/2, and our d from the other slide was 1/4. No, it was 3/4, sorry. Had it written down. Now let's write it all out. Our final answer would be that x plus 1 divided by x squared times x minus 2 squared equals a 1/2 over x plus my b is 1/4 divided by x squared plus negative 1/2 over x minus 2 plus 3/4 divided by x minus 2 squared. And that's your final answer. Thank you. Have a nice day. Bye-bye.